Alright, so in this video, we're going to be solving the October-November 2020 paper 2. And as you guys know that you're only going to be tested on paper 2 now, as per the latest announcement of Cambridge. So I decided to start uploading content of paper 2. So I think the best way to do that would be to start with yearly past papers, and that's exactly what I've decided to do. So yeah, I'm gonna try and solve as much as I can. Ideally, I would have to divide this into two parts, but yeah, let's see. And first of all, thank you for all the support. It just hit 10,000 subscribers, as you guys must have noticed. So again, can't thank you guys enough for that. So yeah, let's get started. So here we have question number 1, part A, which says the cash price of a car is $13,000. Martha pays in installments for this car. Martha pays a deposit of 15% of the cash price. Okay, so let's simultaneously underline what we think is important. So she's paying 15% of the cash price. She then pays 24 monthly installments of $500. Calculate the total amount that Martha, I think I said Martha, but yeah, Martha pays for the car. Okay, so uh, questions like these, you can't really have a head-on approach. Okay, so you got to break it down and see what the question has given you and see what the question is asking you for. Okay, so the cash price is $13,000. All right, she's paying 15% of the cash price. So let's work that out. Let's work out the deposit. All right, so let's work out the deposit. So the deposit is 15% of 13,000. So let's see what's that equal to. 15%, 0.15 into 13,000. So that's equal to 1,950. Then she's paying 24 monthly payments of 500. So that's a no-brainer. 24 times 500 will give us the total amount that she's paying. So 24 times 500 is 12,000. Okay. So let's sum it up. 12,000 plus 1950. So that gives you 13,950. And there you go. That's the final answer. 3 marks in the bag. All right. Now let's do part B, which says the price of a phone is reduced by 12% in a sale. The sale price of the phone is $286. Calculate the price of the phone before the sale. Okay, so if you followed my videos, you must have noticed that I have a very straightforward approach with questions like these. So I make a column for percentage, I make a column for dollars. So this is the reduced price. $286 is the reduced price. So that means this is after discount. So in terms of percentage, this is basically equal to 100 minus 12, which is equal to 88%. Okay, so it has been reduced by 12%, which means it's equivalent to 88%. Before the sale basically means original price, which is equal to 100. So 100 is to x. Let's cross multiply. So 100 times 286 divided by 88. So that gives us $325. So x is equals to 325. Make sure that you write your answer in the space that's provided to you. Alright, so now we're at part C, which says the exchange rate between dollars and pounds is that $1 is equals to 0.71 pounds and €1 is equals to 0.87 pounds. Okay, then it says calculate the exchange rate between dollars and euros. And according to the question, it says you're asked to find out what $1 is equal to in terms of euros. Okay, so here's what I need to do. In fact, let's first understand the question. So you know what dollars are equal to in pounds, you know what euros are equal to in pounds. Okay, and you need to work out what exactly you need to work out what $1 is equal to in terms of euros. Okay, so let's make a column for euros and let's make a column for pounds. All right, now we know according to the question is that €1 is equals to 0.87 pounds. All right, now the thing is, if I can't place dollar here, okay, because this is basically representing euros. However, what I can do is I can write 0.71 here. Now I'll tell you why that is. Because this basically represents $1. Okay, so if I place 0.71 here, what I'm technically doing is I'm trying to find out what $1 is equal to in terms of euros. Okay, however, it's still in pounds, but since it's equal to $1, what I have in front of it is x, which will basically give me what $1 is equal to in terms of euros. Okay, so now it's just a matter of cross multiplying. So x is basically going to be equal to 0.71 over 0.87. Let's work that out. So x is equal to 0.71 divided by 0.87, so that gives me 0.816, and according to the question you're supposed to give the answer correct to 2 decimal places, so 0.82 is our final answer. So there you go. Alright, now we're at part D, which says Samuel invests $1,500 in In an account paying 1.9% per year compound interest, Nina invests $1,500 in an account paying 1.9% per year simple interest. They each leave the money in their account for 5 years. At the end of 5 years, how much more money does Samuel have in his account than Nina has in hers? Okay, so let's make a column here so that we can evaluate the situation in their accounts separately. Okay, let's say this one is for Samuel. Okay, now, so Samuel is investing in an account which is paying 1.9% per year compound interest. So how does that work? That works like this. So 1500 into, if you guys know what the formula for compound interest is that you have 1500 into 100 plus the rate of interest, which is 1.9 in this case, over 100 raised to the power of the number of years that you're going to leave the money in the account for. Now, bear in mind that when you do this, this gives you the total amount. Okay, that's the thing with compound interest. When you use the formula of compound interest, you should remember at all times that what you get as a result is the total amount. Okay, so although in this case the question is not asking you for the interest, but if it were, you would have to deduct the principal amount. So 100 plus 1.9 over 100, bracket close, to the power of 5. Make sure that you insert this as it is. Okay, I'll try and show you what I'm doing in my calculator. Okay, so hopefully you guys can see it. Yeah, so there you go. This gives me 1648.018. So let's just make it correct to the nearest cent, so 0.02. Okay, cent basically means 2 decimal places, all right, in case you guys didn't know that. Okay, now let's talk about Nina. Oops, sorry about that. Yeah, so Nina right here is basically investing in an account which again pays 1.9% per year, but this is simple interest. So the formula for simple interest is basically the principal amount, which is 1500, times the rate, which is 1.9, times the time, which is 5 in this case. And this, remember, will give you just the simple interest. So Nina here ends up getting a simple interest of 142.5. Now if I find out the total, okay, that means I just need to add 1500 to this. So when I do that, I get $1,642.5. So I'll just put a 0 in the end. And then what do we have to work out? We have to work out the amount of money that Samuel has. How much more does Samuel have in his account than Nina? So here's what I'm going to do. The amount of money that Samuel has, which is 1,648.02 minus my last answer. So that gives me 5.52. So there you go. That's the correct answer. 4 marks in the bag. So that was question number 1. Now we're at question number 2, and this is cumulative frequency, statistics. So very important. So basically, so far we've had everyday math, and now we're doing statistics. Okay, so it says a group of 80 students each completed a task. The table shows the time, t minutes, each student took to complete the task. All right. And what do we have to do? On the grid, draw a cumulative frequency graph to represent this information. All right. So immediately, let me see what I have next. Okay, so not much. Immediately, what you and I should do is, we should make a separate row, right, where we can record the cumulative frequencies. Okay, that's very important. So yeah, that's what I'm going to do right now. You guys don't have to be so neat, okay, but yeah, should be presentable anyway. Okay, so this is for cumulative frequency. So for the number of students who took less than or equal to 40 minutes, the frequency is 10. For the number of students who took less than or equal to 60 minutes, the frequency is 10 plus 20, which is going to be 30. And then 30 plus 34, which is going to be 64. And then 64 plus 12, which is going to be 76. And then 76 plus 4, which is going to be 80. And one way to check is that make sure that your final cumulative frequency ends up being equal to the total frequency, which it does in this case. So we're good. Okay, now we have to sketch a cumulative frequency curve. So frequency is on the x-axis, cumulative frequency is on the y-axis. So at 40 we have 10, so that's 1 dot. At 60 we have 30, so there's another. At 80 we have 64. So here one box is basically equal to 2 units because 10 divided by 5. 10 is being split in 5 small boxes. And then at 100 we have 76. So at 100 we have 76. So there's that. And then at 120 we have the total, which is okay. So now I have to make a nice and smooth cumulative frequency curve. So let me tilt my iPad slightly. Okay, make sure that your curve is smooth and there aren't a lot of overlappings, right? Because you may be penalized for that. Okay, then once you've done this, then it's up to you whether you want to join it to the origin. Okay, if you do that, in fact, you should do that. Yeah, bear in mind that you should do that. Okay, so let me just do that again. Yeah, this looks better than the last one. Anyway, so yeah. Then it says the median. Now, median, if you know, is 50% of the total frequency. So that means 50% of 80. Yeah, since that's what the total frequency is. So that gives us 40. So now remember, don't get carried away and think that 40 is your answer. That's not your answer. It is the corresponding value of 40. That's going to be your final answer. So let's find that out. So here we are at 40. Let's look at the corresponding value. So the corresponding value is between 60 and 70. So when you're asked to draw a cumulative frequency curve, or in fact whenever you're asked to draw a curve, okay, so in that case you are given a certain margin of error. So yeah, you can expect to get away with it. Okay, and if I look at the answer to part A, it says correct reading at cumulative frequency of 40. So you got a follow through mark here, which basically means that if your cumulative frequency is incorrect, however you've done this correctly, so you'll still get a mark. But again, try and be as accurate as possible. All right, then we have the interquartile range. Okay, so interquartile range, you should know, is the upper quartile. Okay, I'll just, to save some time, I'll just write UQ minus LQ. So that means we got to work out what upper quartile is, which means 75% of 80, which is equal to 60. Yeah. Now let's look at the corresponding value of 60. So the corresponding value of 60 is, again, try and be as accurate as possible. So 72, 4, 6, 8. So between 76 and 78. So I'm going to go with 77. Right, so let's write 77 here. And then let's work out the lower quartile. Lower quartile is going to be 25% of the total frequency, which is going to be 20. Yeah. So let's find out the corresponding value of 20. The corresponding value of 20 turns out to be, okay, surprisingly all my values are not falling at that particular end of the box, but yeah, this one does. So this is 52. So yeah, this looks good. Okay, so that means 77 minus 52. Let's work that out. 77 minus 52, and hopefully this will fall inside the acceptable range. 25. Yep. So we're safe. The acceptable range is 24 to 28. So you're good. All right, so now we're at part B, which says a group of 160 adults each completed the same task. The table shows the number of errors made by each of these adults. Calculate the mean. Okay, so mean, when you have data like this, okay, frequency table basically. So it's pretty simple. All you got to do is you got to multiply frequency with the whatever it is that you're measuring, which in this case, let's just call it x, sum it up, and then divide it by the total frequency, which if you read the question carefully, most cases it's very likely that will be given to you in the question. Okay, so I'm going to work out f of x. So 24 times 0 is 0, 30 times 1 is 30, 50 times 2 is 100, 96, 64, 40. Yeah, so let's just sum it up. 0 plus 30 plus 100 plus 96 plus 64 plus 40, and divide by the total frequency, which turns out to be 160. So 30 plus 100 plus 96 plus 64 plus 40 divide by 160. So that gives us 2.0625. So since this is an exact answer, it's best to write the exact value, 2.0625. Yeah. Okay. All right. Then it says one of the adults is selected at random. Find the probability that this adult made more than 3 errors. All right. More than 3 means 4 or 5. Or since there is no 6 here, if there were 6, so we'd have considered that. That means you're going to consider the number of adults who made 4 errors and the number of adults who made 5 errors. So that makes a total of 24. All right. That's your favorable outcome. Divide by the total, which is 160. Punch it in your calculator, or if you're smart to do it mentally, go ahead. So your answer either way turns out to be 3 upon 20. Which is the correct answer. Although if you didn't simplify it and gave it without simplifying it, you'd still get away with it. 2 of the adults are selected at random. 2. So that means without replacement. Okay, that's the only way you can select 2 adults. Find the probability that they each made exactly 1 error. Okay, so how many do we have who made 1 error? We have 30. So that means for the first time, the probability is going to be 30 over 160. Okay, and then for the second time, since you've already selected one, you're going to have 24 as your favorable outcome and 159 as your total outcome. Okay, so 30 divided by 160 times 29 divided by 159. So that gives me 29 over 848, which is the correct answer. 29 over 848. All right, so that's that. So far we've just done 2 questions. Okay, Now we're at question number 3, which says complete the table for y equals to x upon 4 plus 2 upon x. Okay, so you get 1 mark for just plugging in the value of x. So make sure that you don't lose marks here. This is just uh, it's just free marks basically. So when you plug in x in this equation, right, so you get the corresponding value of y, which is 2.035. So that's going to be 2.04. Then it says on the grid draw the graph. Okay, so graphs of function. So far everyday math, statistics, graphs of function. Okay, so 0.5, the corresponding value of 0.5 is 4.13. Okay, so 0.5, where do we have 0.5 between 0 and 1, and then what do we have 4.13. Okay, so 4.1, so 4.13, let's just place it at 4.1. Okay, and then you have 1 and 2.25. So the corresponding value of 1 is 2.25. So I'm going to be trying as accurate as possible. I'm going to try and place it between 2 and 2.5. Okay, and then at 2 you have 1.5. So this you can do fairly accurately. And then you have 3. At 3 you have 1.42. So at 3 you have 1.42. So let's lock it at 1.4. And then at 4 you have 1.5 again. And then at 5 you have 1.65. So again I'm gonna try and place it between 1.6 and 1.7. So here we have 1.5, 1.6, 1.7. So let's place it here. And then at 6 you have 1.83. So this will have to lock at 1.8. And then at 7 you have 2.04. So this will have to lock at 2. Okay, so now let's make a nice and smooth cumulative graph by joining these points. Okay, then yeah, okay, not bad. By drawing a tangent, estimate the gradient of the curve of y equals to x upon 4 plus 2 upon x, where x equals to 1. So that means the tangent that the question is talking about will be drawn when x is equals to 1. Okay, so let's do just that. Let's make a tangent at x equals to 1. Okay, so since I'm doing this digitally and you're going to be doing this on your on a piece of paper, so at first I would suggest just place your scale and see what's the best tangent that you can come up with. Okay, and the qualities of best tangent are that it should just touch the curve at x at the point where it's supposed to. Okay, number 1, and number 2 is that the distance of the tangent from the curve should be symmetrical. It's not like from x at before x equals to 1 it's too far away, and after x equals to 1 it's very close to the curve. So ideally it should be symmetrical, which I think it is now, fairly symmetrical. And again, keep in mind that there's a certain range of acceptable answers. So again, that's something we don't count on, that's something that we get away with. All right, so I'm going to try and come up with 2 very nice points that I can read easily. So here's one, and the coordinates of this point are 2, 0.6. right? Whenever you're finding out the gradient of any line for that matter, first be 100% sure what the gradient is going to be, and by that I mean whether it's going to be negative, positive, or stuff like that. Okay, and then here's another point. Okay, the coordinates of this point are going to be 0.1, 3.7. Yeah, okay, so I'm just going to rewrite them over here. 0.1, 3.7 is 1 point, and then the other was 2, 0.6. Okay, now let's find out the gradient. Now remember, the gradient of this particular line is going to be negative. So 3.7 minus 0.6 over 2 minus 0.1. So let's see what this is equal to. 3.7 minus 0.6. So that's that, divided by 2 minus 0.1. So that's equal to 1.6315. So I'm going to lock it at 1.63. And so, wait a minute. 3.7 minus 0.6 over, it should have been 0.1 minus 2. See? So what I said came in handy, that our answer is supposed to be negative. And the acceptable range is from -2 to -1.1. So our answer is well inside the acceptable range. So that means we're good. Okay. On the grid, draw the graph of 2y plus x equals to 6. So for this, let's make y the subject. Okay, so if you make y the subject, so that's going to be 6 minus x upon 2. Right, so I'm just going to plug in points that are easier to mark. Okay, so, and ideally you take 3 points, but even if you take 2, you'll still get away with it. Okay, so in fact I'm going to take 2 to save some time. So here we have x and y. So if I make x 0, y turns out to be 3. if I make y 0, sorry, if I make y 0, so what happens then? X turns out to be 6. 0 times, yeah, x turns out to be 6. Okay, you can do this in the equation, replace y with 0, see what the corresponding x value is. So we have 0 3 and 6 comma 0. 0 3 and 6 comma 0. Okay, so let me do this with a different color that I haven't used so far. I haven't used red. 0 3 and 6 comma 0. Okay, so I'm gonna join these 2 points with the help of a straight line. There you go. Okay, 2 marks. Simple. Write down the coordinates of the point of intersection of, this was bound to happen. So here's one point that I'm highlighting. This point is 3.2. All right, so let's write this over here, 3.2. And then I'm going to write down the other point, which is over here. Oh, sorry, this is with the other line, with the tangent, in fact. This point, which I can zoom in, is point, let me see. It's between 0.7 and 0.8. So I'm going to go with 0.75. Again, try and be as accurate as possible. So let's go with 0.75. So 0.75. And let's check the answers. So, well, you're not given exact answers, but if your line is correct and if the curve is correct, you can expect to get all the marks there are. Then it says the x coordinates of the solution of the equation 3x squared plus ax plus b equals to 0. These x coordinates, in fact, use 2y plus x equals to 6. So basically what this question is trying to tell you is this, in simple words, is that when you try and find the x coordinates of the solution to both these equations, okay, so what you end up with is the following equation. So what and we need to find out the value of a and b. So think of it this way, that this equation came after we equated both the equations, all right, cross multiplied, rearranged, and got it in this form. And then if we were to solve this equation, we'd get the solutions of the 2 equations, all right? So what we need to do is we need to solve the 2 equations simultaneously. And that is in fact exactly what I'm going to do. So y is equals to 6 minus x upon 2. And the other equation is also equal to y. So I'm simply going to equate the 2 equations, all right? That'll save me some time. X upon 4 plus 2 upon x. Okay, so I can't just cross multiply immediately. First I'll have to take out the LCM on the right hand side. So 4 and x are going to be multiplied, so 4x is going to be our LCM. Then we have x squared plus 8. So now we can safely cross multiply, and when we do that, let's see what happens. We have 6 into 4x, so that's going to be 24x minus 4x squared equals to 2x squared plus 16. Right, so let's bring it in the form the question wants us to. So we want the x squared first, which is positive 3, and then x, and then b. So I'm going to shift this 4x squared to the right hand side. So we have 6x squared minus 24x plus 16 equals to 0. Now in the question we have 3, over here we have 6, and if you look at all the other values, they're all even numbers, which means they're all multiples of 2. So I can factor out 2. So we have 3x squared minus 12x plus 8 equals to 0. And if I write this nicely, so we have 3x squared minus 12x plus 8 equals to 0. Since this 2 gets divided by 0, it just vanishes. So a, you guys can see, is minus 12, and b, you guys can see, is 8. So yeah, wasn't too difficult. Okay, so I've solved this question independently. Okay, so I'm going to skip this for now. In fact, I'll post the link to the video where I solved this question. Okay, this was a difficult question, and so I thought I'd just make an independent video on it, so there's no point in doing it again. All right, so however, as far as I remember, I didn't do part B, so I'll just do part B right now. Okay, so it says a different solid in the shape of a cuboid. A different solid is in the shape of a cuboid, sorry. The cuboid measures 8 cm by 4 cm by 6 cm. These measurements are given correct to the nearest centimeter. So again, it's very important that you highlight whatever they're nearest to, okay? Then it says calculate the lower bound of the volume of the cuboid. Okay, so first of all, volume is basically equal to what? Length times width times height. Now you're multiplying 3 numbers, and you want the result to be as small as possible. So ideally what you need to do is you need to make sure that all the the three numbers that you're multiplying are also as small as possible. So that's what I'm going to do. So we have 8. 8 is correct to the nearest centimeter. So that means I'm going to take 1 centimeter divided by 2. So that's 0.5. If I want the upper bound, I'll add 0.5. If I want the lower bound, I'll subtract 7.5. And that's essentially what I'm going to do with every other value. So the lower bound of 8 is going to be 7.5. The lower bound of 4 is going to be 3.5. The lower bound of 6 is going to be 5.5. So we have 7.5 times 3.5 times 5.5. So let's work this out. 7.5 times 3.5 times 5.5. Okay, so we have 144.375. Again, since this is an exact value, I'm going to leave it as it is. 144.375. Maybe one day before the exam, I'll make a video on the difference between exact value and the values that you need to round off. Okay, so I'm going to solve question number 5 and then take a break, and then the rest of the questions I'll cover in the next video. Okay, so we have Geeta has n stamps, Ravi has twice as many stamps as Geeta, Sanjay has 7 fewer stamps than Ravi. Altogether, the 3 children have 108 stamps. So this is more like a logic word problem sort of a question. Okay, and again, for questions like these, you can't have a head-on approach. So you have Geeta, Ravi, and Sanjay. Okay, so I've just written their initials here. So we start off with Geeta, who has n stamps. Ravi has twice as many stamps as Geeta, so that means I'll just multiply the number of stamps Geeta has by 2 in order to obtain the number of stamps that Ravi has. Sanjay has 7 fewer stamps than Ravi, so that means for 7 fewer basically means minus 7. 7 fewer than what? 7 fewer than Ravi. So Ravi has 2n stamps, so therefore Sanjay has 2n minus 7. Altogether basically means their sum, which according to the question is equal to 108. Okay, now at this point, don't get carried away and think that value of n is going to be their final answer, because we'll read the question, we'll come back to it. In fact, let's just do it now. It says form an equation in n and solve it to find the number of stamps Sanjay has. So I'd suggest that you do this immediately. Okay, number of stamps that Sanjay has. So I've circled this because this is what I need to find. Okay, so here's what I'm going to do. N plus 2n plus 2n, so that's going to be 5n minus 7 is equals to 108. So 5n is equals to 108 plus 7, which is 115. N is equals to 115 divided by 5, which is 23. Again, do not get carried away. Work out the number of stamps that Sanjay has. So that's 2 times 23 minus 7, which is equal to 39. There you go. Easy does it. Okay, let's do part B and C. Part B says simplify 6t square v cube upon 5 divided by 3t square upon v square. Okay, so first things first, it's you have a division sign in between, so you got to change that to multiplication, and when you do that, you have to now take the reciprocal. Okay, so now it's up to you whether you want to simplify first and then multiply, or you want to multiply and then simplify. Okay, so I'd rather simplify first. Okay, so you have t square over here and t square over here, so that gets cancelled out straight away. And well, there's okay, so you can see 3 1s are 3 and 3 2s are 6, and that's about it. So v cube times v square, so that's v to the power 5, same basis multiplied, powers are added, and you have 2 in the numerator and 5 in the denominator. So that's it, 2 upon 5, v to the power 5, and that's your final answer. Okay, simplify. So you have a quadratic expression in the numerator and a quadratic expression in the denominator. The difference is that in the numerator you have 2 perfect squares with a minus sign in between, which basically means that we can apply the identity a square minus b square. Okay, and the denominator will have to factorize like a regular quadratic expression. So the numerator can be written as x square minus 4 square. In the denominator, here's what I need to do. 3 times minus 8 is minus 24. So I need to come up with factors of minus 24 that give me positive 10. So you have 1 times minus 24, 2 times minus 12. Okay, so I can manipulate 2 and minus 12. Okay, 2 and minus 12, so that when they're added together, I get positive 10. So instead, what I can do is I can do 12 and minus 2. Okay, so 12 plus minus 2 is equal to what? Is equal to positive 10. So 3x square plus 12x minus 2x minus 8. So the numerator, I have x plus 4 times x minus 4. Okay, a square minus b square, as you guys know, I'll do it over here. Let's drag this over here. A square minus b square, whoops, sorry, what just happened? Yeah, is equal to a plus b times a minus b. Okay, I have a detailed in fact, I have quite a few videos on algebra. If you guys are weak in algebra, I suggest that you go watch that. So in the denominator, I can factor out 3x, so I have x plus 4. Then I can factor out minus 2, so I have x plus 4. And then I have x plus 4 times x minus 4 in the numerator. In the denominator, I have 3x minus 2 times x plus 4. So x plus 4 and x plus 4 gets cancelled out, and now I'm left with x minus 4 over 3x minus 2. And that, in fact, is your final answer. So there you go. Yep, that's the correct answer. No, wait, x minus 4. Yeah. So again, almost made an error there. Okay. So I'll stop here. Okay, I'll do the remaining questions in the next part. So see you guys in the next video. Until then, take care. Bye bye.